So one of the big problems facing developers is how do we manage our files? We have development files, we have server files, we have testing server files, we have multiple users working on these files all together. It's okay if you're a one-man team with one site, but when you start having multiple servers and multiple users that are developing your files, it gets a little bit difficult to maintain. Plus, how do we keep the files in sync with our local development source files to all the different servers that we use? One solution when working with a system like PHP is to use FTP. FTP is basically a file manager for the web. So we'll drag and drop files or upload files and download files between our local server and any one of our development or production servers. And this works okay for basic file transfers, but it's kind of hard to keep track of things. If we have two users pushing files up to a production server, I might have a version that's got some changes that I made, and so I'll push those files up. But if somebody else made some different changes and pushed their version up, we're going to have a conflict. So FTP is okay for a single user, single developer system, but it's still wrought with problems. For instance, let's say that you are working on a project and a client comes to you and says, hey, can you change this system to use the following specifications? And so you frantically go through all your source code and you make these modifications, and then you push them all up to the server, and the client says, hey, actually, now that I see it, I don't really like those changes, can you go back? Well, unfortunately, with just basic file systems, there's no way to do that. You'd have to go back through and hope that you commented the code that you changed so that you could revert the code back. So with a basic structure, we're lacking in controlling different changes, keeping track of those changes, and some sort of way to help manage multiple developers on the same project. So FTP is not really a great solution. So what does that leave us with? Well, fortunately, other developers have come across the same problem. They've developed a couple different ways for us to keep track of files between users, versions, and environments. They've given us Git and SVN. Git and SVN differ from FTP because they're actually systems that keep track of our files. They'll keep track of versions, they'll keep track of changes, and they'll keep track of who actually made the changes. So think of it as a timeline throughout your project's development history. So let's say you're developing a project and the client comes to you and says, hey, you need to use these specs instead of the ones we previously gave you. So you go through, you frantically make all those changes, and then you store a bookmark once you've made those changes. So you have a bookmark from before and a bookmark from now, and you can revert between any of those changes. So if the client comes back and says, actually, I don't like what we did there, can you go back? Yeah, no problem. It's just a simple command in terminal or on the web. Both of these are solid systems. We'll be using Git through a special web portal called GitHub. There are a couple other different systems that actually allow us to hook into the Git repository system. So basically, the way that these work is they create what are called repositories. A repository is essentially a folder that keeps track of itself and its changes. So you go in and you change a single line in a single file, and you push those changes up to the server. The server will know exactly which file you changed and which line you changed. If two users are working on the same file, and you're working on section A and the other user is working on section B, when both users commit those files and push them up to the repository, Git will figure out which changes were made and if they affect each other, and if they don't, it will make a merge between the two files, because it's able to define where sections of those files are and who made what changes. So with Git, multiple users is handled. Versions are handled. We can see a commit that made one change to one file, or a commit that made 6 changes to 6 files. We can see new files, old files, changes at different steps along the path. A really good view of the timeline of the project. We also have the ability to store these files by pulling them into different environments and preventing Git from controlling certain files. Like if you're working in a PHP environment, you might have it ignore your htaccess file for certain projects. Or if you're working in a Node environment, you might have it ignore certain password files so that you can have different passwords for different servers on your ecosystem, and so that other users, public users, won't be able to see those files. So let's look at how we can have a single developer interact with our repository. The repository is basically the file system on the web and locally. So it keeps track of the changes. So this is basically our timeline, our folder. So let's say this user here makes a bunch of changes to a couple different files. The first thing they'll do is they'll add their changes to a commit. By adding changes, they're telling the Git system that the files they changed are found here. So this could add 6 files, or it could add just 1 file if that's the only file you want to send up. The next thing they'll do is they'll make a commit. Once the files have been added, the commit tells the system to place a bookmark at this point. Now keep in mind that this is all local on the local machine. There's a folder system that's hidden from the file browser that will keep track of these changes, what's changed, where it's changed, and how it was changed. So this commit is a local concept. You can make multiple commits. So if you make a change to a file and then make another change to a file, you could make another commit. Each commit comes with a message and a user. So developer A might say, oh, I changed the file to support the Twitter protocol instead of the Facebook protocol. However you want to name your changes or tell other users what was modified. So once you've made the commit, this is all within the local system. The next thing is to move it into our global system. So this is a server somewhere. This will all work locally, so it is good for local storage, but you want to make sure that you're backing it up to the web. So that also takes care of the backup system. So once you're done with your commits, you'll push to the server. When you run a push, it will take all your changes and all your commits in the current set, ones that aren't synced to the server yet, and it will sync them all to the server. So now the repository, which is on a server somewhere, perhaps GitHub or Bitbucket, is synced with your local system. So let's say another user comes in, user 2, and wants to get hooked into the project. When user 2 comes in, they have a couple options. They can either run a clone or a pull. So a clone is a first-time sync with the server. A pull is any subsequent sync with the server. Because they don't automatically keep track of each other, you need to run the commands to push your changes up and to get new changes down. So in a common development cycle, you'll have a bunch of users all running pushes and pulls simultaneously to get files up and down and get their bookmarks that they've committed and files that they've changed up into the timeline. Another common problem is when you have two developers working on the same file. Maybe they're in different parts of the country or of the world, and they're working at different times, but they're not in sync. So user A is working on a function in that file, and user B is working on another function in that file. How do we get source control to make sure that both changes happen in the same file without there being any issues? So Git has figured out a system to handle these different conflicts, and they'll attempt to do a merge. A merge will take the changes that were made in file 1, which Git has been able to keep track of, and the changes that were made in file 2, which Git has also been able to keep track of. And when they both push up and pull, user A will push to the server, user B will pull down, and their system will detect that the two files are slightly different. Or, if they both try to push at the same time, the first user will be successful, the second will get an out-of-date, out-of-sync error. So they'll need to pull files down to make the merges happen before they can push their changes up. And this makes sure that the files stay in sync across users and across the repository. So what happens is, user 1 will make their changes to file A. They'll push those changes up to the server. So they've pushed a commit. They've added the file, they've committed the file, and they've made a push. User 2 will see that user 1 has made some changes to the file that they were working on. So they'll pull in the new changes. Because they were working on different sections of the file, if they were working on the same section of the same file, there might be more of an issue, and you may need to coordinate with the other user whose changes should take precedence, because Git won't be able to figure out which ones are more important. That's a developer decision. But assuming that they worked on different parts of the file, user 2 will see the new changes and pull them in. Git will detect that there was a merge made because the two sections of the file were now combined into one single comparative file. The merge will complete, and they'll have a single version of the file that will contain both user 1's changes and user 2's changes. And then user 2 will do a push to sync with the server. Once this step 4 is complete, user 1 can pull and get the brand new version of the file because they've already been synced with the server. Some of the great features that come from some of the systems like GitHub or Bitbucket, which are basically online controllers of repositories, is the features that they support for open source. This makes it really easy for you to keep your project source code open to the public. The public can download your project, use it in their projects, as long as they follow your licensing. You can attach documentation, you can have a wiki that will show even better documentation than just what's seen on the project landing page. Users of your system can post issues to your project, so you have a built-in issue manager where a user sees that, oh, you didn't update the version number in the most recent files that you pushed to the server. So you can say, okay, I'll go in, make that change, and then you can close their issue. Other issues might come up where a user says, oh, I'm using this on an old version of Windows and it's not supported. So you would look into that issue, maybe have a back and forth with that user, make the changes, and then close their issue referencing a recent commit that you made. So that's really helpful for the users of your projects to help contribute to the betterment of your project. Finally, they have the idea of pull requests. So let's say that there's a big issue or a big change to your system that a user wants to make. Maybe they want to also support Twitter login as opposed to just having the Facebook login. They can download your files to one of their local machines, make the changes as if they were a collaborator, and then push the changes up to your project. Since you're in control of the project, this will come through as a pull request. And what this means is that the user has made some changes to the project and they want to integrate them with your project. You can decide whether or not the changes fit well with the architecture of your system or not. And if they do, you can choose to immediately integrate their request, their commits, with your timeline. So this is called a pull request because the user has requested you to pull down their changes. And you can decline them if you want, if you choose not to support their changes or vice versa. There's also the idea of forking a repository. Forking a repository duplicates the entire timeline into a brand new repository. This allows other users to take your project, make modifications to it, and show their changes separately. Maybe they wanted to integrate a pull request, but it didn't fit with your plans or your architecture, so they started their own system. And this sort of helpful connection between users and developers and the systems is really great for an open source environment. Fortunately for us, the forks also show what they were originally forked from, so we don't have to worry about users getting confused about which version is the correct version. So in the end, we're going to be using Git for all of our projects. We'll advise during this section to use this for every single separate project that you create for any of the tutorials you do, even if they're on a different system. Make sure that you're using Subversion or Git to keep track of the changes you're making locally and syncing them with the server so that if anything ever goes wrong, you have a backup somewhere else on the internet. This is also really helpful for syncing with new users, so a multi-user system or an open source system benefits really greatly from these repository management structures. So any project you do, make sure you have a separate repository for each one, and if you're creating open source software, this is a great place using GitHub to share your changes. It also works really well as a portfolio, so if you're new to development and you want to start building out the work and showing potential employers what kind of development you do, having open source projects that other users aren't contributing to is really helpful to share with potential employers because they can look at the code that you're actually writing and see how you code. They can see the changes you make, the messages you commit with, the quality of your projects, the quality of your documentation and your tests. So it really helps to show a window into your development lifestyle. Plus, with the backups and the multi-user collaboration and the commit timeline, this system is almost a no-brainer.